Hello and welcome to Chapter 3 review for Algebra 2 Trig. This is a review for the Unit 3 test coming up. Special thanks to Vishnu for the notes provided in this video. Okay, so the first concept we're going to cover is finding the degree of a function. We can see the degree of the function here is 2 and the leading coefficient here is also 2. This function is already in standard form. The next function, its degree is 5 because it's the highest exponent. The leading coefficient for that is 4, and this is not in standard form, so we'll have to put the terms in order of the highest degree to the lowest degree. And for this function, we can see the degree is 4 because it is the highest exponent. The leading coefficient is 15, and the standard form is already provided in the function. Now let's write each of the following quadratic functions in vertex form. We can see that the vertex form is y is equal to a times x minus h squared plus k. And so we'll need to find the vertex, which is h and k. Minimum or maximum depends on the leading coefficient of the function and whether that is positive or negative. So let's find the vertex form. So we can define the function and then so we're doing this by completing the square, moving 7 off to the other side, and then completing x minus 2 squared and then adding 7 back, or adding the number back. So that's how we get x minus something squared. So now we can map the vertex form to the function we have here. And we can see that h is 2 and k is 3. So vertex is h and k, and h is 2 and k is 3. That means vertex is 2, 3. Line of symmetry is basically a line that is straight through the vertex, and its equation is x is equal to h. We determined earlier that x is equal to 2, or h is equal to 2, so this is x equals 2 is the line of symmetry for this function. So we can see here it's based on the sign of the leading coefficient. Leading coefficient here, I believe, is positive. Yeah, so it's a positive 1, and that is going to result in the function having a minimum. So f of x would look something like that, and the minimum would be 2, 3. Next up, we're finding the vertex and the roots. So let's find, so h is negative b over 2a. We can see that b is 2 and a is 1. So we will have to find h, which is negative 2 over 2, and h will be equal to 1. and k is f of h. So we plug in -1 into f of x. It's actually, I think, -9. Yeah, -10 plus 1 is -9. It's sort of a bit of an error. But the vertex is at -1, -9. Real roots, just set it to 0 and factor. So what two numbers have a product of -8 and a sum of 2 is -4, or +4 and -2, because we have to get +2. So it's +4 minus 2. And then our roots will be -4 and +2. Okay, so time to graph the function. As we determined earlier, the vertex will be at -1, -9, not -1, -11, as shown on the screen. And these are our roots, and we draw a nice parabola through them. Okay, now it's time to find the vertex form of the function given the point through which it passes. So we can just set up the vertex form equation again, and then use the point that it gave us for x and y, where the x is the x value and the y is the y value, and the x value of the vertex is h and the y value of the vertex is k. So if we put that all into the function, we can find a, the a that's in the vertex form. And we find that a is equal to 1/9. And then we can rewrite our vertex form equation knowing what a is. Okay, and now for standard form, we will just expand the x minus 1 squared and multiply it all by 1/9, then add 2. So just expand it all. Yep. Okay, now it's time to determine whether this is a polynomial function or not. That one wasn't. This one is. This one has an odd jump in between, so it is not. Okay, now for n behavior. So let's describe the left and right behavior of the graph. So the degree of this polynomial is 4, which is positive and even. So our n behavior is going to be as shown on the screen, shown on the left side. As x approaches infinity, y approaches infinity, and as x approaches -infinity, y approaches infinity. So it's now time to factor and find the roots of this. We're going to use the PQ method, where you take the factors of the n term and the factors of the leading coefficient, which are the factors of -36, factors of 1, and divide them. Then plug them into your synthetic division to test whether they are factors or not. So we're going to use the PQ method. This has a name, actually. So we can see here we're going to use the rational zero test, which has PQ stuff, and the factors of -36 and of 1, which we've laid out here. And for the sake of time, I've just determined that -3 and 3 are factors that work. You would go through all of these numbers, but we've determined that -3 and 3 work. And so we're going to have those two, and then the function that the polynomial that comes out of that is x squared plus 4x plus 4, which is x plus 2 squared. So our roots are going to be 3, -3, and -2. So the multiplicity of each factor, we can see that x plus 3 appears once, so -3 has a multiplicity of 1. We can see that x minus 3 appears once too, so plus 3 has a multiplicity of 1. And x plus 2 is squared, so -2 appears twice and has a multiplicity of 2. So we can sketch the graph here. Remember our end behavior that we discovered previously, where you pass through 3, go to -2 because it's bounce at -2 because of the multiplicity, go back around 3, and approach infinity. Okay, so now let's do some long division. We're going to divide this polynomial here by x minus 2. Let's get dividing. So let's multiply 6x squared by x minus 2 to get 6x cubed. And when we do some subtraction, so divide, multiply, subtract. In this subtraction stage, we get -19 plus 12, which is -7x squared. And then the next stage, bring down, which is plus 16x. Now to multiply -7x by x to get -7x squared. But then you also get the plus 14x there. And you subtract that, and you get 16 minus 14, which is 2x. Then you multiply 2, but you multiply 2 by x minus 2 to get 2x minus 4. And you actually get 2x minus 4, so you get a remainder of 0. And you get a cleanly divided polynomial. Now, if you're asked to put it in this specified form, then go ahead. So you know your two factors, x minus 2 and the factor we just discovered. Okay, now let's do some synthetic division. So we put 1 up in the box, and we put our coefficients. Then we bring down 1. 1 times 1 is 1. -10 plus 1 is -9. -9 times 1 is -9. -40 plus -9 is -49. So that's our remainder. And our polynomial becomes x minus 1 times x minus 9 minus our remainder of 49. Let's do another one. So here all our coefficients are 1. And we are dividing by the root, which is -9. And let's do some synthetic division. So 1, bring down 1. 1 times -9 is -9. 1 plus -9 is -8. Negative 8 times negative 9 is 72. 1 plus 72 is 73. 73 times negative 9 is negative 657, which gives us a pretty big remainder. So we can see x plus 9 times x squared minus 8x plus 73 minus a remainder of 656. Okay, now it's time for the remainder theorem. Remainder theorem basically states plug in x to f of x to find the remainder when the polynomial is divided by x. And if we plug in negative 2, plug in negative 2, we get negative 57. Okay, and then we can do synthetic division to check. Okay, so let's just see how to do these problems. So we can just, for this problem, we can use synthetic division. Right, we can do synthetic division, get a remainder of 0. That's how you show that something's a factor or something else. And then you do more synthetic division for that one. And then you do like the PQ method here to find out all the things that you can do synthetic division with, and then you do synthetic division. And do that for the rest of those questions there. Okay, so now let's find a polynomial function given its roots. So if something has a root at 4i, it also has to have a root at negative 4i. So that is also a factor. X plus 4i is also a factor. Then you could multiply x minus 4i by x plus 4i to get x squared plus 16. But you multiply x squared plus 16 by x plus 3, and you get our lovely third degree polynomial. So that's our polynomial. Then we should ideally put that in standard form. Right, x cubed plus 3x squared. Yep, plus 16x plus 48. Okay, so now let's do Descartes' rule of signs. Descartes' rule of signs saying basically what it says here about the amount of positive and negative zeros. And then now that we know how many zeros the function has, or how many of what type of zeros, we can go and factor it. So we can do some nice grouping here. And we get 2x squared plus 1 times 3x minus 2. And then from there, our x values are going to be 2/3. And I think we're going to get a complex root here because x squared is going to be something negative. And so I think we're going to get I root 2 over 2. Yep, so that's I root 2 over 2. So that's the end. Good luck on your test. See you in the next video. Be sure to like and subscribe. Thanks for watching.